We're looking at doing double integrals over rectangles. I'm going to do quite a lot of examples here. So I guess that's why I was havering there. I didn't want to get started too early. I'll take it, I hope, to the point where you can say, I'm cool, I know how to do it, right? Now, each one of these questions is going to be a little bit different to show you some of the different ways in which the question can be asked, and also to show you that there are different strategies depending on the information. I want to integrate this. Do you notice it's going to be with respect to y first and then x second? You won't see these numbers with x equals or y equals. You'll just see 0, 1, 0, 3. Pay close attention to the order they write these. They aren't always x and y. In fact, they're more likely to be y and x in this textbook for some reason. So let's do this guy. And I'm going to do them over here. So I'm going to do the integral from 0 to 1 of 2xy, the square root of x squared plus y squared with respect to y. What technique do I need to use to integrate this guy? That's why I've got this little thing over here.
Chain rule.
Chain rule? Well, chain rule is what we use for differentiation, but maybe that's the name that you're using. But what would you do if you don't get the right name?
No, by parts, I meant.
Oh, integration by parts. Nope, not this time, although I can imagine questions where it might be.
Yeah, I think it's a U sub.
It is. I want you to think of that as 4, and that is 2. This is like the integral of 2y square root of 4 plus y squared. If you see it that way, do you see a U sub? If you tried integration by parts, that square root would go really ugly on you really quick, and it wouldn't work out. So I'm going to choose ugly guy inside square root. So the reason I chose this question is because we need to do a U sub in order to find its integral. Now, when you do the differentiation, it's going to be with respect to y because of that. So that gets you what? What's x squared going to get you with respect to y?
0.
Right. So are you all happy that you get 2y? Now, I do it this way. You basically do the crossover, and then you get the isolate the dy. So this integral here becomes 2xy square root of u 1 over 2y du. Won't the y's cancel? Agreed? So I'm now looking, oh, and the 2's cancel. So I'm now looking at x square root of u du. That's going to be x u to the half du. Now, do you see how different it looks from Calc 2? In Calc 2, would we be trying to figure some way of replacing that x in terms of u? But not in Calc 4. It's just a constant. That's like 5 u to the half. Now, next stage, power rule. Add 1 to the power, divide by the new power. Last stage, well, I guess second last stage, is this guy. And this is the fella that you now evaluate at y equals 0 to y equals
1.
1, thank you. Don't know where my brain is going here. So, come on. And if I plug in 1, what do I get? I get 2/3 x, the square root of x squared plus 1 cubed. And if I plug in 0, I get take away 2/3 x, the square root of x squared cubed. That becomes 2/3 x, the square root of x squared plus 1 cubed. That guy actually, square root 2 gets you x cubed times that x. I hope I got this bit right. You get that. So we are now going to do the integral from x equals 0 to x equals 3. 2/3 x, the square root of x squared plus 1 cubed, take away 2/3 x to the 4 dx. Now, if I've made any minor arithmetic mistakes, you can fix them yourself and you go back to that. This double integral, when you integrate it with respect to y, now turns into this single integral. This single integral is a Calc 2 question, right? After you do the first stage, you're just left with a Calc 2. So let's see how we're going to approach this. Would you agree this term is just a power rule again? How are you going to deal with this one? Because I'm not going to finish this question.
I think that would be another u sub.
And it will. And what will the u sub be?
X squared plus 1.
Right. So do a u sub of x squared plus 1. And can you trust me, it'll take a fair amount of work. But eventually you'll get that one and you will be done. So do you see how complex and convoluted this particular double integral ended up being? So that is our first example.
Hello?
Done. Hello. Someone said hello.
I think James is answering his phone.
Okay, I will mute you also. We don't hear his conversation. I'm sure he wouldn't like us to. Are we cool with that first one? Right. So you're going to have to do, don't get too complacent and think, oh yeah, they're all just polynomials. Do it with x's, do it with y's, everything's fine. No biggie. No, they're not all polynomials, right? There's some u subs. Hopefully do my second one. This one. Okay. You've disappeared on me. Something's not right. I'll get two people trying to get in. Maybe that's what caused it. I'm lost. I don't have my thing. The thing. I found it. Here it is. God, that was annoying. Right. You probably were looking at this all the time, but I couldn't find it. Okay. Let's look at this particular one. Have you seen the way in which they're describing the rectangle? They're calling it R, and R is all the points x, y. So the x is between 0 and 3, and y is between -2 and 2. dA, in the situations that we're talking about, is this guy. He is also allowed to be that guy. So you can decide who goes first and who goes second. It makes no difference as long as you change the integrals. So let's set this fella up. Do you want me to do the x first or the y first? It really doesn't matter. Pick a letter.
Y.
Why?
Okay, so if I'm going to do y first, you write them down that way, agreed? And doesn't that make the y's then should go from -2 to 2? And the x's then should go from 0 to 3. Now that, I hope that wasn't too big a deal, right? You could figure out that, right? Now the sneaky part. I can integrate this stuff with respect to y, get the answer, and then integrate it with respect to x. But if you look really, really carefully here, do you notice that you can separate the x's and y's out? And if you notice that you can separate the x's and y's out, it is typically a good idea to do so. Because what I can now do is that. Remember the rule yesterday that says the integral of f of x times g of y can be separated into two calc 2 integrals. Now, would you agree that's just going to be much easier to deal with, a lot less work, right? Isn't that just a calc 2 question? And isn't that definitely a calc 2 question? So can you imagine that you get the answer to this and it's 42, and you get the answer to this and it's 5, then when you're finished, that would be your answer. Now, I'm not saying that's the answer, but let's look at process. What method would you use to integrate 3x over x squared plus 1?
U sub possibly?
Yeah, and who's the u sub going to be?
X squared plus 1.
Go for it. Would you agree that's a baby one? It's just a power rule. Right, so that's how you will finish that question off. So basically dot, 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 right? Now, could I have just battered my way through the usual way? You know, integrate with respect to y and plug in the two y values, then integrate what's left and do that. Yeah, sure I could. It would just be more work. That's it, just more work. Are we cool with that? Because it's okay for me to say it's easy or obvious and it's not. So are we good? I don't see any dissenters. Let's look at this one then. This is a double integral over a rectangle. It doesn't look very much like it because it isn't written, you know, double integral with all the stuff in it, but it is nonetheless, that's what it is. So find the volume of a solid that lies under this plane and above this rectangle. So first thing I'm going to do is take this information and rearrange it, because don't we need a function in terms of x and y? And this is a function or an expression in terms of x, y, and z. Essentially, that guy is z. So what I'm going to do is take this, which is the equation of a plane, and rewrite it in the form z equals, because then that can fit in here and we're ready to go. So that's the trick in this question. So as long as you do it to both sides, it's okay rule. So I'm going to subtract 2x from both sides, and I'm going to subtract 3y from both sides. And then I'm going to divide everybody by a rather ugly -4. So that's -3. I believe that becomes plus a half, and I believe that becomes 3/4 y. Okay, would you want me to do x first or y first this time?
X.
X it is, so we're going to do x first. This fella becomes our f of xy. And since we're doing x first, that means what? -1 to 1. Since we're doing y second, -1 to 2. And this integral is now set up. I'm going to do dot, 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 but let's talk it through. Aren't we going to integrate -3 add a half x plus 3/4 y with respect to x? Let's see what that gets you. -3 would get me -3x. Great. 1/2 x would be a power rule, so 1/4 x squared. What would 3/4 y get me?
3/4 xy.
3/4 xy. Not 0, because that's what you get if you differentiated it, but 3/4 xy. Right? And then won't you plug in x equals 1 and x equals -1, subtract them, and you'll be left with something with y's in it, and then you do it again. So, am I cool with ... You don't need to say, right. We're good?
Yep.
Okay. Let's do another one of that kind of written type. Suppose I keep track of the time here. Darn it. Can you pretend that I wrote all this stuff down so I don't have to rewrite it? And I'm going to give you a new expression. It's going to be x squared plus 2xy plus y squared minus z equals 0. So that's going to be the surface, and the rectangle is going to be x between -1 and 1 and y between 0 and 1, right? So you can imagine I've just filled in with words. So this is not a plane, this is just a surface. We just use the word plane when we know it's a flat piece of paper. Technically, it isn't a plane just another surface, it's just a flat surface. And every other surface is curved, so I guess this is a curved surface. Now, if you rearrange this, would you agree you get that eventually? So my integral is going to be, I'm going to do it, and I'll do y's first. So y equals 0 to y equals 1. And then it's going to be x equals -1 to x equals 1. So I know I'm doing y first and then x second. And this guy is my function. So it's going to be x squared plus 2xy plus y squared. Are you happy about how you can take the written version of this question and construct the double integral that will find you the volume? Because that's what a double integral is essentially doing. It's taking a rectangle on the ground and it's going upwards till it meets the surface. And you're basically finding the volume of that shape. So can we pretend that I know what the shape looks like? And it looks like that. And then all you've got basically you're finding the shape of that weird cuboid, right? Really nice in the bottom, really straight going upwards, but the top's got a little curvy bit because that's what the surface looks like in that little window. And I think someone was asking last time, so since I've got this picture, I'll try a different analogy. Can you imagine that is a funny shaped solid loaf of bread? Now, can you imagine me taking one very small slice of that bread? And can we pretend that that's the area at position X? Now, if you take that, can't you slice it for different values of X's? If you found the area of all those slices and you stuck them together, wouldn't that be the volume of that loaf of bread? So when you're doing the dx bit, see this bit here? Can you imagine you're finding the area of one very tiny slice of the object? And then you're integrating it over the entire loaf of bread. I don't know if that analogy helps you a little bit better. It's a very visual analogy. Technically, it's not 100% a proof, but it's good enough to get a gist of what you're doing, right?
Yeah.
Okay. So I think what I'm going to do now, oh no, I was going to go to the homework, but I have got one more question that I want to do, and then we can look at the homework. And it's a guy we haven't done yet. It's find the average value of a function. Now, if you were doing it in Calc 2, isn't the average value of a function 1 over a, the integral from a to b of f of x dx? Right, and a, I guess I should call it b minus a, right? That's a better way of saying it. You remember that guy? So what's the average value of a function going to look like when you move from a one-dimensional, well, essentially a two-dimensional situation to a three? Well, it's 1 over, that's where the AI was coming from, the integral, the double integral of your function dx dy over a region R, and A is equal to the area of rectangle R. So do you see, you just basically find the double integral. You find the area of your rectangle and you divide the area, right, I should say the volume of your double integral with the area of your rectangle. And that's called the average value of the function. So can you imagine the whole rectangle, and at every single point the function has a certain height? What you're trying to say is, what's the average height, right? What's the average Z value? And this will do it. So let me pick a question. Suppose the function is x squared y cubed. And let's suppose that the rectangular region is -1 to 1 and 0 to 1. I'm trying to do nice numbers so I don't get caught up in the minutiae of calculation. Then the area of the rectangle, the area of R, well, wouldn't you agree that's 2 and that's 1? So 2 times 1, it's 2. That wasn't too hard. So the average value of the function is 1/2 the double integral of x squared y cubed, and I'm going to do dy dx again because I feel like it. That's going to go 0, 1, and that's going to go -1, 1. Now you notice because I'm doing y, these are 0 and 1, right? So I was a bit careless, but I can get away with that. It's 1/2 the integral from x equals -1 to x equals 1. And now we focus on doing that guy. X squared y cubed integrated with respect to y. It's not as ugly as it could be, isn't it? Just a power rule. So you add 1 to the power and you divide by the power and you evaluate it at 0 and at 1. If you plug in 1 here, you'll get 1/4 x squared. If you plug in 0 here, you just get 0. So what you end up with is 1/4 x squared. Now that's a Calc 2 question, isn't it? As you always get when you do this. So power rule and divide by the new power. Evaluated at -1 and at 1. You plug in 1, you get a 12. You plug in -1, you get -12. But subtract -12 means you're adding it. So you get, technically speaking, 2/12. The average value of that function is 1/12. Can you imagine that the surface that we're talking about is a hill? And you cut out a little rectangular piece of that hill. And you're saying, what's the average height on that piece of the world that you're looking at? In this case, it wouldn't be very tall, it'd be 1/12. Now, if that function was representing temperature at given points, then the average temperature in that piece of metal, that rectangular piece of metal, would be 1/12 of a degree, right? So average value of a function, a three-dimensional function, is an important, useful thing to be able to calculate. Are you comfortable about the formula 1 over the area of the rectangle and then the double integral? So for the next few minutes, let's have a look at how the homework asks those questions. And that'll also give me a chance to find out if I've screwed up anywhere and missed something out. Okay, Austin, I got your issue. I have no idea what that is, but it's something to do with the speed limit, I suspect. Right, that was an earlier topic. Okay. And where the heck are you? Here you are. Okay, if you're wondering why I'm turning a funny angle, it's because my second screen's at right angles to my first. So let's start at the top. Would you agree that's just a classic double integral? Do y first, do x second, power rule. Yeah, move on, nothing to see here, right? Would you agree question 2? Same issue. You could FOIL that out and integrate it, or you could use you know, a little bit of strategy and do it without that. Nothing special here except they're slightly awkward, right? Done one like this yesterday, I think. Oh, you recognize that guy? Recognize this guy? Now, find the volume of a solid. Isn't that very similar to one I did? You see, in this case, you're going to have to rearrange this guy to be z equals, and that'll be your function of x and y. And then the x's go from -1 to 2, and the y's in this case go from -1 to 1. In this question here, won't you have to rearrange this function so z equals, and that'll get your f of xy. Have you seen this notation here? The first square brackets are always the x's. So this is saying x is between -1 and 1. And the second square brackets is always the y's. So this is y between -2 and 2. So if you're wondering where the limits of integration for x and then for y is, that's where they are, right? So it's just a different way of telling you. Oh, isn't that one already good to go? You've got the z equals. This fella has a z equals 1, which we've not talked about, but there's the rectangle. Agreed? Now, let's figure out what's going to happen. I want you to pretend that that z equals 1 was not mentioned. So you're going to take from the floor all the way up to the curved surface, right? And let's suppose we did it and the answer was 42. So far, so good. Now, if you look at this rectangle, isn't there a rectangle that's what, 6 by 4? And it goes up 1 unit. So aren't you basically cutting a big cuboid off the bottom of your answer? So the first answer, without anything done to it, was 42. Won't you take away the 36 from the bottom? That's how you get the answer. So if you ever get a question and it says z equals 1, z equals 2, and a rectangle, just do the entire volume the normal way, and then just cut off whatever the cuboid on the bottom was. So if it's from 0 to 2, can you imagine it's length times width times 2, and whatever that number is, subtract it from your volume and you're done. That makes sense? It's a strategy. There we go. Would you agree that question 10 is just a disguised version of what we already know? They are not telling you what x and y range from directly. But if you look really carefully, shouldn't you be able to figure out what x's and y's start and finish at? For instance, what are the range of values for x's? What's the smallest to the biggest? Looking at those 4 corners.
-5, 5.
Agreed. And what's the y's going to go?
0
0
to
to
5. Right. Do you see now that they've got 3 ways to tell you the limits of integration? Couldn't they just say 0 less than or equal to x less than or equal to 1, right? They can do it like that. Couldn't they give you coordinates? Couldn't you do square bracket 0, 1 cross square bracket 0, 2? They're just the same information served to you in different formats. Nothing really special about 11. Would you agree it's pretty much what you see is what you get? I guess the letters aren't X and Y, but I mean, I hope by now you don't care what letters of the alphabet they use. Isn't it the same math whether it's an S or it's an X, right? It's still a barrel or whatever it happens to be. Let me phrase this question slightly differently. Can you separate question 12 into 2 pieces?
Yeah, pretty easily.
Very easily. Would you agree that one of them is going to be the integral of x dx and the second one's going to be secant squared dy? Now, do you notice in this case they haven't said dx dy, they've done the generic dA, which for rectangles means dx dy, right? I guess the only question I need to ask you is, what's the antiderivative of secant squared y?
Tangent y.
Yeah, well done. Right. My Calc 2 are doing that right now. They're not up to speed, some of them, but that's not to be expected, right? You got to do a few more of these before you get used to them. 13 is just ugly, would you agree? 13, I would do in one particular order rather than in the other order. If that makes sense. What should I do, X first and Y second, or Y first and X second? Which do you think is just going to be less work?
Y first, X second.
Yeah. Because if you do it Y first, isn't it just going to be some ugly log eventually? Right. The X second is going to be messy. But it's going to be even worse if you did it first and then tried to do the Y second, right? So I would say. This guy here is just what you see is what you get. Would you agree that this 3y squared minus x squared plus 5, isn't that your f of xy? Agreed? Won't the x's go from -1 to 1 and the y's go from 1 to 3, so you're good to go with that one? There's just the way it's phrased. Is there anything, I won't try to give you too much help here, is there anything in 15 that you could do?
You can separate the x's and y's out.
Yeah, there is a term that you might see if you go hunting. It's called variable separable. Sounds like bad grammar or that I made it up, but that's its name. And this is a situation that is described as variable separable. Now, if you separate it as 2 over 1 plus y squared dy, and then 1 plus x squared dx, it comes out okay. What is, I'll just call it 1. What's the antiderivative of 1 over 1 plus y squared?
Inverse tan.
Correct. 16's ugly, but nothing particularly weird. What do you think you need to do in 17 to get the answer? What's happening in 17? Because it's not ready yet.
You gotta solve for z, set that as your f of xy, and then you.
Yep, you've done the hard bit. The minute you said that, you've killed it, haven't you? Right, turn the z into, and then it's not even that bad an integral, isn't it? It's just some power rule stuff. And just to finish with, a baby one. Would you agree there's nothing to worry about in 18? It's good to go. Don't need to fix it. Don't need to worry about order. They're even telling you the order. Right. Did we learn some cool stuff today?
Yeah.
Yeah. Oh god, that was a half-hearted yeah. Okay, since you're not giving me the kind of enthusiasm that I was hoping, you're going to have to listen to a joke. So the next time I say, "Did we learn some cool stuff?" I want to hear much better enthusiasm. Yeah. Well, Ben's doing it now, but too late. Okay, you ready, guys?
Yes.
Brenda, are you ready for this joke? You are? Okay. I'm going to tell a joke about the Pope. I figure out that I'm equal, I pick on everybody, then it's fair, right? So here goes for the Pope. So I hope I don't offend any people who have religious bent. Pope arrives in New York, gets off the plane, jumps right into a taxi. Still got his, all his Pope gear on. Goes to the taxi driver and he taps him on the top of the head and says, "Look, that plane was late. I have to be in the United Nations. I've got a big speech to make. I'm going to be late. You need to get there right away." Taxi driver turns around and says, "Look, it's Russia. There's no way in the world I'm going to get there. I'll do my best." And so he takes off, and 5 minutes later, the Pope's tapping him on the shoulder and says, "Look, this isn't working. You're not going fast enough. I'm late. I got to get there." And so the taxi driver says, "Well, if you think you can do better, why don't you drive?" So Pope says, "Okay, I will." So they stop and they get out, and Pope gets in the driving seat, and the taxi driver gets in the back. He's hardly enough time to shut the door, and Pope puts his foot down, and back wheels go up, and he's off. He's going down one-way streets the wrong way. He's going round corners in two wheels. He's breaking every speed limit in the world. Gets pulled over by the cops, of course. Cop goes over and taps on the window, and the window goes down, and he looks into the driving seat, and all the colour goes off his face. And he gets on his radio and he says, "We're in trouble." The sergeant says, "What's up?" He says, "I've just stopped the most important person in the world." And the sergeant says, "You've not gone and stopped the president, have you?" He says, No, it's not the president. It's somebody more important than that." The sergeant says, "Well, who is it?" He says, "I don't know." He says, "Well, how do you know he's the most important person in the world then?" And he says, "Well, he must be. The Pope's his chauffeur."
Yeah.
Oh, I got tutor there. That was it. Leah, did you like that joke?
I did. I liked it.
That,
My
and
wife.
nobody
way-
could really get offended. Agreed?
Should we do roll?
Good idea. Let's do roll. We'll finish off in a few minutes. I wanted to just give you a heads up on tomorrow, but give you a few seconds to do that. So have you all learnt your lesson? The next time I say, did we learn some cool stuff? You're going to have enthusiasm, right? Okay. So what we're looking at, this is going to be the intro to the next section, but I want to get this part done. We're going to look at double integrals over non-rectangular regions. There's a good word. Right now, we've been doing this guy. And the guy in the bottom's been a rectangle. And when he was a rectangle, we did the integral, say, from A to B and the integral from C to D of some function, f of x, y, and you could do the x's and the y's in any order you like. And that guy represented the volume of that weird shape as it met up with the surface, right? Let's look at the puzzle from a different perspective. Suppose that region was not a rectangle. Suppose that region was a circle, right? So you had a circle on the bottom and you went up and you met the surface. Wouldn't you like to find the volume of that kind of shape? Suppose the shape on the bottom was a triangle or a trapezium, or really any shape you like. Right? Wouldn't it be nice if we could find a technique for the volume of that shape? Well, we can. I'm only going to do the floor, but I'll show you how we would approach that. Let's suppose that the region on the bottom, this guy here, called R, was that triangle. Okay. Now this triangle has an equation, and let's suppose its equation is 2 take away x, just for argument's sake, right? Then that would be 2, that would be 2, and this would be 0. So I'm going to set up my integral. The function f of xy will not change in this circumstance, right? It's going to be whatever it is, not a biggie. And in this particular question, what you do is that you imagine a random vertical rectangle at position x. Now, in that particular case then, as you start at one side and move your rectangle to the other, won't x go from 0 to 2? And that's how you get one of the two limits of integration. To see in this case, it's a number, right, from 0 to 2. In these kinds of questions, the outside integral is always going to be two numbers. If you ever write it down and there's an x or a y here, it ain't right order. Now, what does the y value look like at this typical random place? Would you agree at this point here, isn't the y value 0? Now, at this point here, isn't the y value 2 minus x? So we put in here that the y is 2 minus x and that the y is 0. Do you notice now, oh, and dy. Do you notice now that what we've managed to do is adapt the rectangular formula to now cope with triangles? And if you find the integral using y equals 0 to 2 minus x with respect to y, and then you integrate that answer with respect to x. So let's put a guy in. Let's suppose that the surface that this triangle is being projected up to, let's just say for argument's sake that it was x squared plus 2y. So we're going to do from x equals 0 to x equals 2. We're going to do y equals 0 to y equals 2 minus x of this function with respect to y and then with respect to x. Are you still with me? Okay. Now let's see how that works in practice. Integrate x squared plus 2y with respect to y. Okay, so I'm going to integrate x squared plus 2y with respect to y. Well, won't the x squared become x squared y? And won't the y squared, the 2y, become y squared? And then wouldn't you evaluate it at y equals 0 to y equals 2 minus x? So that now I'm going to forget about the color scheme. It's going to be from x equals 0 to x equals 2. If you plug 2 minus x for y, you get x squared 2 minus x plus 2 minus x squared. And if you plug y equals 0, would you agree you just got a whole load of zeros, so I won't bother writing that down, dx. Do you notice that what I now have is just an ugly expression in x's? Can I integrate that calc 2-way eventually and plug in 0 and 2 and we're finished? Yeah, I guess I could take it one more line. X equals 0 to 2, that's 2x squared, take away x cubed, plus 4 take away 4x plus x squared dx. I guess I really need one more line then. So what am I going to get? I'm going to get 3x squared, take away an x cubed, take away a 4x, add a 4.
Mr. Robertson,
Yes.
okay, so shouldn't it be 2 minus x squared over 2 plus 2 minus x cubed over 3 because you're integrating with respect to y?
Oh, you think I've made a mistake here?
Yeah.
I have, haven't I?
I think.
Yes, I did. I did. Oh, no, let's check. Let's check. Integrate with respect to y. X squared
Oh,
y.
never mind. Oh,
Right.
never
Okay,
mind.
we're cool.
Oops.
Yeah, it's easy.
Sorry.
I'd rather you brought that up and I was okay than let it go and I was wrong. So, would you agree that this question is pretty much done, but a little bit of tidying up and off you go? So that's what tomorrow is going to bring. Tomorrow we are going to look at how do you find double integrals over non-rectangular regions. So the types in non-rectangular regions are triangles, halves of circles. That's most common ones that come to the top of my head. And I'm going to finish here.